right? So, and then right after class today, right after class today, the quiz number 2 will be available. You will have it available until Thursday at noon, right? Thursday noon. So now, if you have like 5 questions, for instance, to solve, and then you have until Thursday to do that, you see, I think it's not, there's no excuse not doing it, okay? So we're going to talk about it right before the end of the class, okay? But now we're going to continue on. We done chapter 2. We did 2.1, right? I mean 4.1. That is the inverse of a function. We did that just to complete it. You see, and if you have f of x, just to review what we see, is f of x equal to x plus 3 over 5x minus 1, right? Find f minus 1 of x.
Professor, we can't see your screen.
Okay, you cannot see my screen. Thank you very much for telling me that. I completely forget about it. Thank you. All right, so now you can see my screen, right? Okay, so my previous class, I had a class just before you guys, and the teams kept on cutting off, like, it happened like 2-3 times during the session. So I hope it will not happen for us. I mean, I am at CCBC here at Owings Mills, so it is like CCBC internet. So I think it's good internet, but maybe it's team itself. Maybe it's the teams itself. So if it does happen, don't go anywhere. I will just go ahead and reconnect, right? Again. So just to review what we did last time, if you have some like that, so I let you like about, some 2, 3, 4 minutes to do that by yourself and to find f minus 1 of x. Go ahead, please. All right. Okay, so all right. So can somebody like walk us over the steps, please? How to do the steps? You know, if you see that in the quiz, what steps you're gonna do? Somebody volunteer themselves, please.
Okay, we can take y equal to x plus 3 over 5x negative minus 1.
Y equal x plus 3 over 5x minus 1. Thank you. And then what do you do next?
Multiply all of them by 5x minus 1.
Okay, first of all, tell me, what is your goal? What you gonna get at the end?
X.
You're gonna get at the end x by itself. Everybody agree with that? We want to get x by itself at the end. So you said you multiply both sides by 5x minus 1. Thank you very much, right? And then what you do? What you do next?
Oh, okay. Multiply y by 5x minus 1.
You are distributing, right? It's going to be, so when you distribute the y to the parentheses 5x minus y minus 1, you get 5xy, right? Minus y equal to x plus 3. All right, tell me now what you did next.
Okay, we can factorize by, no, not factorize. We can add, we can subtract 3.
Subtract x from both sides, right? That is good. And then at the same time, what you do to the y? At the same time, we add y to both sides. You see, because again, I want to have the x terms on one side. You see, get x terms on the same side. Okay, so we get 5xy minus x is equal to y plus 3. Now comes the step you were talking about. Now what you do now on the left side?
We factorize by x.
We factorize by x, we get x times 5y minus 1, right? Equal to y plus 3. And then the very last step, we
divide all of them by 5.
So we get y plus 3 over 5y minus 1. And that is what we wanted to get. So now we write now as an answer f minus 1 of x. Since I'm asked to find of x, I'm going to change y to x. It's going to be x plus 3 over 5x minus 1. Thank you, Sheriff, right? So was it Sheriff or was it Elijah? Who was talking to me?
Sheriff.
Sheriff, okay. So, all right. So that is, you know, this is the example. We have more steps, you know, and we like this type of example because they have more steps, right? Okay, so now, of course, in general, trying to find the inverse can be like, it's really very hard, you know. In general, in math, we even don't try to do that in general because it's really hard, right? Okay, so, and this right here, we just want to talk about a couple of stuff before we move on, right? Is this, if you have two inverses, before we even do this, right? Before we even do it, what do you think? What is your suggestion? If you compose two inverses, we say f circle f minus 1 of x. When you compose two inverse functions, what's going to happen, you think? Common sense. What's going to happen?
They're going to cancel out.
Thank you very much. That is natural because they are inverse each other. When you put them together, what one does, the other one will undo it, right? And vice versa. So what's going to be the answer here? If they cancel out, who's going to be left here?
Zero?
No, zero. No, it's not zero, but you know, The x, exactly, the x, because they gone. You see, what f minus 1 did to x, f undid it, right? So this will be x left. And it's going to be the other way around also. If we say f minus 1 circle f of x, they're going to cancel out. Okay? In any, it doesn't matter one way or the other way, they just cancel out, right? Now tell me, what is the potential difference between the two x's? I mean, this is like some type of theory. This is some type of theory question. Let me, if somebody, you think about it. What is the potential difference between the two x's, the green x and the red x?
One would be negative.
I don't know. You see, x is just a variable. There is a major difference between them to where they belong. The difference is from there, where they belong. The x, for instance, the green x should belong where? Should belong to the domain of what function?
F of x.
Which function we apply? Look at the green. Look at the green formula. Which function was applied first? Which function was applied first to x?
The f of x.
The f minus 1 of x, right? The green one. If you look at the green formula, the function we apply first to x is f minus 1, right? So this x should belong to the domain of the inverse, while this x should belong to the domain of f. That is a major difference between them, right? But the two formulas, they tell you exactly the same thing. They tell you when you compose two inverse functions, you should get x. For instance, we say f of x equal to 5x minus 1, and g of x, f minus 1 of x is equal to x plus 1 over 5. Check that f minus 1 is correct. How we can check it? We can check it is when we compose them, we should find x. If you plug in one of them into the other one, we should find x. In both ways, right? If you plug in f minus 1 into f, we should find x. If you plug in f into f minus 1, we should find x. Right? That is, the way to check my answer. Okay? So for instance, if I do f circle f minus 1 of x, is going to be 5 parentheses x plus 1 over 5, and then minus 1, right? Okay, so this gone, it's going to be this 2 gone, it's going to be x, you see? So which means my answer is correct, right? And both ways, if you go the other way around, you should also find x. All right, that's what we say. So when we compose two inverse functions, so how this could help in the test? You see, in the test we are doing, knowing this only helps if you want to check your answer, okay? But sometimes checking the answer can be harder than doing the stuff itself, right? This only helps, for instance, if you have a multiple choice question. If our tests were multiple choice, you can do that, right? If we give f of x and we give like 4 choices, which one is f minus 1 of x, right? Let's say I don't remember how to find f minus 1. What is the process? I can go ahead and compose them and see is the one that gives me x is the right one, right? For instance, let's say we say this. We say f of x. We say f of x equal x cubed plus 1. And we say f minus 1. So we say a f minus 1 of x is cube root of x plus 1. Right? We say b f minus 1 of x is cube root of x minus 1. And we say c f minus 1 of x is cube root of x minus 1. You see? Let's say I'm a student. I don't remember. It's been a while. I don't remember exactly how to find f minus 1. I forgot the process, right? But I do remember when you put them together, they should cancel out, right? Okay, so you see that way you can go ahead and check the first one. If you get x, check the second one if you can get x, etc., right? But now, what do you think? Is if you know how to find f minus 1, do you think it's easier to check choice by choice, or do you think it's easier just to go ahead and do it? What's going to be easier?
Check by choice.
Check by choice by choice. This could be hard, actually. You know, if you compose them, if I know the process is to do x cubed plus 1 equal y, and then minus 1 minus get x cubed is equal to y minus 1, and then take the cube root, etc. You see how fast this stuff is? If I have to check one by one, I have to go ahead and plug in this one in here, right? And see if I get x. And if I don't get x, I go to this one. You plug in here, etc., etc. This could be hard, right? Okay, that was just a parenthesis, all right? So now, very, very lastly, and then we're going to open up chapter 3, is how to graph f minus 1 of x. To graph f minus 1 of x, what you do, we flip over, reflect the graph of f over the line y equal x. It is understandable. I don't want to dig into this stuff right here, but it's understandable why the line y equal x will be the axis of symmetry. Why? Because when we go from f to f minus 1, right, the x becomes a y and the y becomes a x, right? This is like, you know, they change position. I mean, they change, right? The x becomes a y and the y becomes a x. Since, you know, the x becomes a y, the y becomes x, the only people that will not change is the people where the x and the y are equal in the first place, right? You see, if x and y are equal in the first place, then if x becomes a y and y becomes x, do you see any change? It's the same thing, right? You see, for instance, right here, this point right here, 3, 3, right? If this is on the graph of f, what's this point tells you? It tells you f of 3 is 3, right? It tells you f of 3, this is x, this is a y. It tells you f of 3 is 3. When you reverse it, what you get? If you find the inverse, what you get? F minus 1 of what equal what? The same point, what you get? F minus 1 of 3 is equal to 3, right? You see? So that point doesn't change. It's going to be still 3, 3, right? So which means all these points where the y equal x, when we graph f minus 1, this point right here, if any point is y equal x, that point will not change, right? Okay. So for instance, right here, if I have this graph right here, tell me, to you, this graph looks like the graph of what? This graph looks like the graph of what function?
Square root function.
Thank you very much. This looks like the graph of square of x, right? So now this graph, does it represent a one-to-one function? What do you think? Does it represent a one-to-one function?
Yes.
What tests it has to pass to say yes?
A horizontal line test.
The horizontal line test, right? Okay, the graph passes the horizontal line test. So this graph is a graph, is the graph of a one-to-one function. Now I wanna graph the inverse without doing the work, right? You know, I wanna graph the inverse. Look, what it tells me, I have to reflect over the mirror. The mirror is a line y equal x. This is this line right here. This is a line y equal x. Okay. My graph, if I wanna graph the inverse, I have to reflect, I have to flip this graph over that line. Now this mirror is a little bit complicated because it's not a horizontal mirror, it's not a vertical mirror, right? So the flipping is a little bit more complicated. How you do it actually, so if you look at it, is this right here, you see? And then this. You see, that is a graph of, that is the graph of the inverse, right? So you flip it over the line y equal x. So in the transformation of functions, how many flippings now? If you count this one, how many flippings we have seen?
One.
If you count this one, how many flippings we have seen in the transformation of functions? Do you remember the section 2.6?
Wasn't it 6 or 4?
So we have, if you want to graph negative f of x, how you going to flip the how you want to flip the graph over what?
Over the x-axis.
Over the x-axis. You see that you have to know that, you know, if you want to do that on the test, you have to know it. If you want to graph f of negative x, you're going to flip it over what?
Y-axis.
Over the y-axis. And now if you want to graph f minus 1 of x, you're going to flip it over the line y equal x. So we have 3 flippings. This one, you're going to flip it over the x-axis. This one, you're going to flip it over the y-axis. And this one, you're going to flip it over the line y equal x, right? Okay. So just, you know, just in case we ask you to do that, okay? Now, you know, for the upcoming quiz and for the, you know, for the test, I generally don't ask about graphing the inverse. I generally don't do that, right? But in Alex, you know, etc. Remember, if you ask you to graph the inverse, you flip the function over the line y equal x. Remember that, okay? You flip the function over the line y equal x. All right. So that is, you know, what could have said about the inverse. First, what you have seen, what is a one-to-one function? We said the graph has to pass the horizontal line test. After that, how to find the inverse. And we did over and over some select problems, right? You know, some problems that are like easy, 2 steps, and some problems that are more than 2 steps, okay? And if I have to ask you something on the test or quiz, it's gonna be like, just like, you know, the examples we did. Now we're gonna open up chapter 3, which is about polynomial function and rational functions. Chapter 3, this chapter is very important, by the way. Polynomial and rational functions. Okay, so, and the first one we have seen, we're going to see, we'll see a particular polynomial, which is quadratic functions. What you call quadratic functions. By the way, this is a category of polynomial functions. This is like, you know, a particular functions, particular polynomial functions. So we're going to start them just like, you know, like apart because they are easy, okay? You know, we study them apart because they are easy, okay? So we know how to deal with them. A quadratic function is any function of the form f of x equals ax squared plus bx plus c. Any function like that is called a quadratic function. Now, the word quadratic, we have 3 terms, right? We have ax squared plus bx plus c. What do you think? The word quadratic refers to what term? Of the three terms, the word quadratic refers to which one?
A.
The term ax squared, right? So you have to have x squared to say this is a quadratic function. You have to have x squared. And for us to make sure x squared is right there, the a cannot be what number?
0.
The a cannot be 0, right? If the a is 0, then the function becomes what type of function? If the a is 0?
Linear.
It becomes linear. Thank you very much. So the a cannot be 0. This is what you call a quadratic function, right? So this is the general form. Of course, right here, I guess all of you heard about what is the shape of the graph, right? The graph, isn't it shaped like that? Or like that, right? The graph will be a parabola. The graph always will be a parabola. Okay? The graph is a parabola. So now, do somebody know when the graph opens up, what makes the graph, in what case the graph will open up? Do somebody know? When what?
When a is positive.
Thank you very much. The graph opens up when a is positive and opens down when a is negative, right? Do you know what is the name we give to this point, the minimum point or the maximum point? Do you know what name we give to them?
Minima and maxima.
Yeah, they are minimum, maximum, but they have a name, a particular name for this type of graph. They call the
Extremum.
They are extremum, which refer to maximum, minimum. Yes, I agree, but
Vertex.
they have a particular name, vertex. Thank you. The minimum point or the maximum point is called the vertex. Okay, that is called the vertex. The minimum point or the maximum point is called the vertex. So now we will see in this section how to find the vertex of a parabola. We will see that in this section, how to find the vertex of a parabola. So how we read the vertex? You see, this is how we use the vertex. For instance, if I have this, and that is my sub, and here I have 2, and here I have 10, right? My vertex is 2, 10. What my vertex tells me? It tells me this: the minimum value is 10, right? Reached at x equal to. Okay? The minimum value is 10. When do we reach 10? When x is 2. This is what the vertex tells you. The minimum value is 10, reach when x equals 2. All right? So if I have this one right here, if I have this vertex now, and my vertex reads 5, negative, 20. What it tells me? Can you write the same sentence about the same sentence? What
The
it tells me?
maximum value is negative 20 when x equals 5.
Thank you. The maximum value is negative 20 reached when x equals 5, right? Every time your question is about a minimum or maximum, every time you hear that in a question, you know your answer will be in the vertex, right? Your answer should be in the vertex. Every time you hear the question, what is the minimum, or when do we reach the minimum? Your answer lies in the vertex, right? For this topic right here. So this is how important the vertex is. It tells you what is the minimum value, what is the maximum value, when do we reach it, etc., right? So now, we saw the standard form, and we're going to see the vertex form. I mean, we saw the general form. Now we're going to see what you call the vertex form or standard form. It is a form that will tell you what is a vertex. If I have f of x equals, if I have f of x equals a parentheses x minus h plus k, h squared plus k, right? When I have this right here, this is what you call the vertex form or the standard form. You see, when you have here, what is the vertex? The vertex is a point H. The vertex is a point HK. Okay? Every time, why we call it the vertex form? Because when you see this form right here, you can read exactly what is the vertex, is HK. And do you see the relationship between H and K? Can somebody tell me what is the relationship between H and K?
Not like the value for the center of a circle.
Yes, it's gonna be, no, I mean, it's gonna be how to shift the parabola, etc., etc. Here's a relationship between H and K. What is it? How much is the f of H? When you plug in H for x, what you get? Replace, substitute x with H. What is f of H? It's gonna be a times H minus H squared plus K, right? So this is 0, it's going to be K. F of H is always K. When you have the vertex, F of the H is equal to the K, right? Okay, that is the vertex form. For instance, when I tell you F of X equals 5x minus 3 squared plus 7. How much is the vertex? What is the H? What is the K? What is the H? What is the K?
H3, K7.
H of 3 and K is 7. Why you didn't say H is negative 3?
Because in the formula we have minus H.
Thank you very much. In the formula we have minus. You see, the H is the number that makes the parentheses equal 0, right? The H is the number that makes the parentheses equal 0. Okay? If I agree with that. So how this parabola opens up? I mean, how this parabola opens, up or down?
Up.
Up.
It opens up. This parabola opens like this. And it tells me that point is a 0.37. It tells me the minimum value is 3, reach at, I mean, the minimum value is 7, reach at 3. You agree with that? Okay, so now g of x, I give you another one. And you tell me what is the vertex. G of x is negative 4x plus 10 squared minus 9. What is the vertex here now? What is the H? What is the K?
10, negative 9.
Okay, good. But remember, the H is the number that makes the parentheses equal 0. So is it 10 or negative then? To find the H, you have to set x plus 10 equals 0. So how much is x equal to? Negative 10. Yes. For the H you always have to solve. But for the K, you write whatever number you see there is negative 9, right? Everybody see that? Everybody see this nuance, okay? Between the H and the K. For the H, you have to solve whatever parentheses, you have to solve it equals 0, right? Is the X that make it 0. For the K now, it's just whatever number you see outside, right? So, and this parabola opens down, And that point is a point negative 10, negative 9. Okay? It tells me the maximum value is negative 9, reach as negative 10. Okay? So now, of course, one of the first issue would be how to find the vertex, right? That's going to be the first issue. So for instance, if I say this, if I say f of x equals 3x squared minus 12x plus 13, right? Just looking at that quadratic function, can you tell me what is the vertex? Can you guess what is the vertex?
No, you have to, don't you have to change the form?
Yes, you see, it's very hard. Just looking at this, it's very hard to say the vertex is this or vertex is that. It's very hard. I mean, maybe somebody can do it if they are very good in, if they are very good with, some mental math, right? Okay. But if you want to say the vertex, we have to do a few steps to write the vertex form, right? So we're going to do that too. We're going to do them together, right? The vertex form. And here, we're going to remember some old technique that we have seen in chapter 1 is completing the perfect square. You see, in the vertex form, you have a perfect square, right? You have a perfect square right here. You have a perfect square. We have to get a perfect square here. We have to get it. So now, do you remember how to complete a perfect square? For instance, if you have x squared plus 8x, somebody remembers what number we need to add to get a perfect square?
Half of the middle term?
Exactly, half of the number square, right? Half of 8, which is 4, 4 squared is 16. Do you remember that?
Can you hear me?
Yes, I can hear you. Yes, I said you are exactly right. You know, if the half of the number square, right?
Yeah, sorry, my mic hasn't been working.
Yeah, I can hear you. Okay, half of the number square. So everybody remember that technique? So we get x plus 4 all squared, right? For instance, if you have x squared minus 14x, what is the number we need to add to get a perfect square?
49.
49, thank you very much. And when you add 49, which square you get?
7.
X minus 7 all square. Thank you. Everybody remember that technique? You're going to use it here. But where is the hic here? Why we cannot go ahead and just go ahead and add a number? Why we have to do something? What do you see different from the two examples up? What do you see different here?
It's a number before the A.
Thank you very much. You see, there is a number in front of the x square, and that bothers me, you see. If the number in front of the x squared is not 1, then my technique would not work, right? What I do, I have to factor out that number. That number has to go, so factor out 3. From where? From the x terms, right? Right, these two right here, I factor out 3. I do this equal to what? 3 parentheses x squared minus 4x. And then I don't involve 13 into the factoring. I don't. You see now, look at the green parentheses. Now I have what I want, right? Now I have x squared by itself, right? I don't have a number in front of x squared. Now I can go ahead and add a number, complete a perfect square, right? It's going to be 3 parentheses x squared minus 4x. What is the number I need to add to make it a perfect square? What is the number I need to add to make it a perfect square?
8.
Is it 8?
No, 4.
It's 4, right? Thank you very much. We need to add 4. Okay, now comes something very important. You see, in math, There's a technique in math. You add something just to take it away, right? In the real life, you don't do that. You see, in the real life, you don't add something, just take it away. Or people are going to say you are crazy, right? If you just move something and you just bring it back, some people say, why you do that? Why you move something and you just bring it back, right? Okay, but in math, we do that a lot. We add a number just to subtract the same number. Okay, for instance, I have x over x plus 3. You see? What would be the incentive for me to add 3 and take it away? Can you tell me why I would do that?
Get x by itself.
To simplify, right? Because when I do that, look happen. Okay, my original expression was x over x plus 3. This is my original expression. Now, when I do that, look what happens. I can do x plus 3 over x plus 3 minus 3 over x plus 3, right? I can split. And now how much is this? It's 1 minus 3 over x plus 3. Basically, the only fact doing this small action allows me to simplify, to rewrite my expression, to rewrite it like this, you see? You see? And if you do calculus one day, sometimes you have to do that, you see? Very important. Same thing here. I add 4, whatever I have to add here, I have to take it away. Okay, whatever I added, because the 4 was not here, right? If I want to conserve the same expression I had before, if I want to keep it the same value, I have to take away whatever I added. Now tell me, the question is, how much did we add, actually? Did we add only 4?
It's 12.
Thank you. We added actually 12. Everybody see where the 12 come from? The 12 comes from here, right? So I didn't add 4, I add 12, so I have to take it away. I have to do minus 12, right? Before we move on, everybody understands this move right here? We added 4 to make it a perfect square. Now, when you add anything you add to an expression, you have to take it away. If this was an equation, we would add on both sides, but we don't have both sides here. This is not an equation. This is just an expression. When you add something, you have to take it away, right? Okay? Or when you multiply something, you have to divide by the same thing, okay? So here we added 4, but the 4 is added inside the parentheses, and the whole parentheses is multiplied by 3. So actually we added 12. So you have to take 12 away, okay? When you do that, look now what you have now. We have 3 parentheses x minus 2 all squared plus 1, right? And that is a vertex form. So what is a vertex? What is a vertex then? 2,
1.
1. Yeah. You see, that was very hard to guess from the beginning. The 2, 1 was very hard to guess from the beginning. All right. Okay, so I'm going to give you this example, but thanks God we have a formula for the vertex, so you will not need to do all that. But it is a good technique to know. So do this one right here. F of x, find the vertex form equal to negative 5x squared, right? Minus 40x. Hold on. All right, go ahead. Do the steps we just talked about to get the vertex form, please. All right. Okay, I think you guys are the steps, right? So what is the vertex? Can somebody tell me the vertex they got?
I got -5 times x plus 6 squared minus 141.
-5 times x plus 6 squared minus 140.
Minus 141.
141, right? So can you confirm this answer? Somebody can confirm this one before we go over the steps? Or do you got something different? All right, so first what you have to do for the -5, these two right here, what you do? We factor out -5, right? Now we have to watch out the signs, right? It's gonna be x squared plus 12x plus 39, right? Okay, now it's gonna be -5 x squared plus 12x minus what? Plus what?
36.
Plus 36, thank you. And then we need to
add 39 and add 195.
Exactly, thank you very much. You see here, we do not subtract. It's not said we have to subtract every time, no. We have to cancel the action we did, right? If we add it, we subtract. If we subtract, we add, right? Actually here, when you distribute here, right here, have you added or have you subtracted? You subtracted, right? If you want to cancel the subtraction, what you have to do then?
Subtract because add because it's a negative.
Exactly, thank you. You have to add, answer 140 is 180, right?
It's 1.
Everybody see that? You have to cancel whatever action you did.
I got 195. It's not 195.
Yeah, I'm very bad at. Is 150 plus is 150 plus 30 is 180, right? Isn't it? 36 times 5 is
180.
180, yeah.
Oh.
So then that would make it plus 219.
Exactly. You see, when we say here, our example, why we subtracted 12? Why? Because the 3 times 4 is positive 12. I need to cancel that. I need to cancel positive 12. The only way to cancel positive 12 is to subtract 12, right? But here, when you do the multiplication, you don't get a positive. You get a negative. This is negative 180. To cancel negative 180, you have to add positive 180, right? Everybody see that, the nuance? So now we get -5 x minus x plus 6 all squared plus 219, right? That is the vertex form. So now what is the vertex now? -6, positive 219, right? And my graph is directed like this because of the -5. So, and that vertex is -6 and 219. So I say the maximum value is 219 reached when x equal to -6. All right. Okay, so now I was saying there is actually a vertex form, which means some people took the general form ax squared plus bx plus c. We do the steps, right, ourselves, and then we get to the answer, and we give you the answer. That is a vertex formula, which will save you all this stuff right here, okay? So just like the quadratic formula, there is a vertex formula right here. I'm about to write vertex formula, and I would advise you to memorize it to save your time a great deal of work, right? To save yourself a great deal of work, right? So if you have If f of x equal to ax squared plus bx plus c, actually the vertex is where a is not equal to 0. The vertex is a point negative x over 2b, negative b over 2a, I'm sorry. And then f of negative b over 2a. F of negative b over 2a. Somebody is telling us the h is always negative b over 2a. Somebody is telling us that. Now, do you believe them? Of course we do. You see? Instead of doing all this right here, look what this formula, how cool this formula is. So we have negative x squared minus 60x, etc., right? So if you have f of x is equal to negative f of x equal to, let's take the first one. The first one is, let's say the second one, negative 5x squared minus 60x plus 39, right? Instead of doing all the work we did before, to find the vertex is very simple. First, what I say, to find the vertex. First, we're gonna write what is negative b over 2a. What is b? So a is negative 5, b is negative 60. So negative is gonna be negative 60 over 2 times negative 5, which is 60 over negative 10, which is negative 6. Isn't it negative 6 here? Right here, right? You see how quick it is? That is the first. Second, to find, remember we said f of h is always k, right? We said, that is, I have found my h is negative 6. Now I need a k. How much is a k? To find a k, I just plug in negative 6. Second, here what I do, plug in negative 6 back into the equation. F of x, right? So f of negative 6 is negative 5 times negative 6 squared minus 60 times negative 6 plus 39, right? So this is going to be, this is 36 right here, which is negative 180 plus 360 plus 39, which is 180 plus 39, which is 219, you see? Instead of doing all these steps, actually, we have the vertex formula. You just need to memorize it, right? If you memorize the vertex formula, you're gonna save yourself some algebra steps, right? Okay? If you memorize the vertex formula, you're gonna save yourself some algebra steps. Okay? So let me...
Is there a reason we have the 2 different ways to find vertex, or is it just more like a proof of concept kind of thing?
Yeah, so this happens always in math. In math, any formula that you see in math comes from somewhere. So unfortunately, in 163, we choose not to sometimes not to show you where the formulas come from, because from the experience, if we spend time to do that, we don't have like a lot of time, right? And then if we spend time to do that, it's going to confuse some students, right? For instance, I didn't show you where the quadratic formula comes from, right? I didn't show you that. But if it was like, a math major class, before we even give the formula, we have to show where the formula comes from, right? So now, when you have a problem, you can choose to repeat the same steps where the formulas come from, or you can just go ahead and apply the formula, you see? For instance, what you did here is to repeat the steps where the formula come from, actually, what you did here. You see, step number 1, number 2, number 3, etc. Or, like in science, math, physics, chemistry, we always have formulas. And if I know the formula, you are very welcome to apply it, okay? So problem is, a formula is meant to be memorized. You have to memorize the formula. If you don't memorize the formula, then you have to repeat them. Then you are obligated to repeat the same steps. And that can take you a lot of time, a lot of calculations, okay? But knowing the formula is very good in math, right, actually. It's really good in math or physics, by the way. See? So if you have this f of x equal to 2x squared minus 16x minus 1. Find the vertex, please. Go ahead. Using the formula, right? I'm not asking you to repeat the steps. We did the steps, we already did the steps, I use the formula to find the vertex. You see, unfortunately, this happened right at towards the end of our class. You know, I think the internet was so bad today, so I was disconnected from the session for a minute. All right, so okay, can you tell me what is the vertex here using the formula?
-4 and 95.
-4 and 95.
Yeah.
I thought for -33.
4 and -33. Okay, so let's check. You have two possible answers. So what is A?
2.
What is B?
-16.
Okay, so the H here is the first we do -B over 2A, which is -16 over 2 times 2. So which is 16 divided by 4, which is 4.
Negative. Yeah.
So we have two negatives and they cancel out and we have 4. So which means my H is 4, right? Comma. And what's going to be then the H, the K now, we plug in 4 back to the equation. F of 4 is 2 times 4 squared minus 16 times 4 minus 1, which is 32 minus 64 minus 1, which is -32 minus 1, which is -33, right? So that is a vertex. You see, and this will save me all those steps of the completing the perfect square, doing this, doing that. You can do that if you want to. I know I have some students who prefer that way, okay? But that way is not friendly for any, I mean, so look, if you have this one right here, f of x equal to 7x squared minus 9x plus 1. You see how the calculation could be a little bit harder here? Because if you do 7, it's going to be x squared minus 9 over 7x plus 1, right? Do you see what number you have to add here to make it a perfect square? I mean, you can do it, okay? I'm not saying it's impossible, but it's not friendly, okay? It's not very, very friendly. All right. So I think, you know, we're gonna stop right here. When it comes Thursday, we're gonna do a couple of more practice, how to find the vertex, how to graph a parabola. This sounds like a review, you know, of 1/83, something like that. So now, if you go to a test, the quiz will open up. The quiz will open up right after class. You see, I go to your class here. When I go to quizzes here, I see quiz number 2. I mean, those people who have accommodations, I give you more time according to your accommodations. Quiz number 2 will open right after class 2:05, right? And you have until 21st, which is Thursday, 12 o'clock, submission time. When you go here, when you go into the quiz right here, you will see the PDF file. Just like quiz number 1, you're going to see the PDF file where you have the questions. I think it's like 4 or 5 questions, something like that, maybe 5 questions, okay? We have the questions. You will have 35 minutes for those who don't have accommodations. You will have about 30 to 35 minutes to finish it, right? Okay, so don't open it until you know you are ready. Don't open the quiz, because once you open it, once you open the quiz, you start the quiz, then it is timed. After 35 minutes, you will have about 10 more minutes or something like that. You know, just I give you that accommodation to submit your assignment here, submit your quiz to here, just like you did with quiz number 1. Submit your quiz to here, where you can upload your file. If you have a single PDF file, I would appreciate that, because that would help me, save me a lot of stuff. You know, if you have a single PDF file. Some people, for instance, the last test, some people sent me like, you know, 8 pictures. I mean, I have to go back and get a PDF file myself, and it takes me a lot of time to do that, you see. So if you have, you know, the scan, you know, you can scan with your cell phone, and you have to practice how to get a PDF file before the test. You know, take a free paper, scan it, and see how to get a PDF file. Do it right now, you know, do it, you know, Don't wait for the test or quiz to do that. You know, this will help me a lot of time. Actually, if that happens, when we do a test, I will grade faster. What takes me a lot of time to grade is some people sending me like 10 pictures, you know. Some people sending like more than 10 pictures. I have to go ahead and upload each picture, get a PDF file, and this takes me a lot of time to finish. So if you can, you know, practice getting a single PDF file, that helps me a lot. Or a single Word file, it does help me a lot. Okay, so don't miss the quiz. You have a couple of days. You have until Thursday noon to, not Thursday like to 11:59. It's not Thursday 11:59. It's Thursday noon. You have until Thursday noon to upload your quiz, which is 5 questions. So there is no excuse not doing it. There's absolutely no excuse. If I don't see your submission by 12 o'clock noon Thursday, you get a 0, right? And if you open the quiz, please try to respect the time, because it's very easy for me to know when you started the quiz and when you submit it, right? So please, okay, you know, and do it seriously. Is it like 5% of the grade? You know, it does help a lot, you know. All right, everybody. You have any questions? All right. So see you Thursday. And please do not miss the quiz, please. Right?